Hi and welcome. This video demonstrates how to develop, test and deploy our first SCRAMBLECODE application. Let's start by creating a new project, our Hello World project. We'll save that and then add a source file for our main class located in the same directory. Double-click the tree node to open main for editing, and we'll save both the project and the source file. Now we add a code snippet for the main class. Just double-click to select it. Now we have a main class with a main function as the entry point of execution. And let's make a simple test by returning a sum of the arguments to verify everything actually works. Syntax: check the code and compile it into encrypted bytecode, right now stored in memory only. Now open the test execution form, and before executing the code, let's check the default setup. We are using the latest compilation stored in memory, and this will be executed by the targeted DLL here. We'll call the main function with these parameters and start execution. The results are reported here. The VM is loaded in memory in 3 milliseconds, and this includes a public key authentication of the bytecode signature. The VM is then called with these parameters, and their sum is returned correctly. And it did the execution in less than half a millisecond, here rounded down to 0. Now we'll expand the code by adding a function to create a Hello World message. Write func and press Ctrl+J to open the code snippets with a filter. By the way, this is just a text file you can edit as you want. And now select a suitable function snippet and change the name. To save time, I have prefabricated the body for this function, but essentially it will assemble these words into a message and store the message and the length in 2 VM cells. Not the most amazing functionality, but it gives us something to debug later on. Please be aware that each VM has a memory area to store values in a grid based on rows and columns. We want to return a result, and default it is 0. But we use a try-catch structure to ensure that if something goes wrong, the returned result is 1. We can securely call our function in the try section, and if some error occurs, it should be reported as an error message in a VM cell, I just press Ctrl space to find the library function for this. Okay, as mentioned previously, I want to be able to debug the execution, so I must switch on these project properties. This will add extra instructions to our compiled bytecode to trace and record the code execution in detail. I will also specify that a compilation unit file containing a snapshot of our code should be generated on each compilation. This will be used by the debugger. Save the files, and finally add a trace command to specify where the recorded code events are to be saved. We will use an event file in the same directory. So, syntax check, and compile to our compilation unit file. And now we are ready to execute and debug the code. This time the main function arguments are left alone, but we want to check the VM cells after execution, so we scan the cells for row 1 and column interval 1 and 2. Now it is executed, and here are the results. The hello world string and the string length exist as VM cells. So let's open the debugger and check the execution. Initially, the debugger contains neither code nor any trace events. These must be loaded first as a setup. So we start by loading a snapshot of the executing code as a compilation unit file, and then we load the recorded events. Please note, it is possible to export these settings as a setup file, which the IDE can load automatically the next time the project is debugged. Now the trace events can be listed, and the source code matching the events is loaded. The recorded events can be debugged very similar to debugging an ordinary binary. Here I single-step each code event. Notice how the function call is presented in the call stack. And the value assignments are visible as traced values for each code event. Values are presented in red, and code use a black color. Now I just single step all the way through the code. The last event is when we write the recorded events. It ends the list of events, and it means that the actually returning of the result is not recorded. Once the code is tested, we want to deploy the encrypted bytecode. For a release version, we must switch off all debug functionality as a security precaution. Then we specify how a copy-paste operation should format and split the bytecode into strings no longer than 1,000 characters. And finally, we remove all trace commands related to debugging. Then save and compile. And finally, just paste the bytecode from the clipboard. Now with this predefined format. This is the encrypted bytecode. All in all, a bit more than 5,000 characters, ready to be included in a source file or simply deployed anywhere as text. Thank you for watching this video. More information is available at SCRAMBLECODE.com.